So this is my cross-section slicing project submission. Just an overview first. We have my project. It's kind of hard to put in the screen there, but so I did Tigger, and then my cross-section area is obviously his tail, and I did it by semicircles. So to start off, because it's vertical and they're not functions, I obviously had to put it in terms of x instead. So I first put it in terms of x and made my two functions, which came out to be 1/6 sine of 4y plus 4 and 1/6 of cosine of 4y plus 1. And then from there, I went into Google Sheets and I set my intervals. I determined that because the two graphs never actually intersect, that I figured that if I did from 0 to 8 in terms of y, that I would have plenty of space because my foam board was 1/4 of an inch thick. So I did 8 inches long, and with a 1/4 of an inch foam board, it was 32 total slices. And so then from there, I went into Google Sheets, and I kind of split up, I kind of set like my intervals for each slice. So I have 32 total slices, all 1/4 of an inch thick. And then I started from the left side of the interval. So like my first slice's y value was 0, my second slice's y value was 0.25, and so on and so forth. And then from there, I plugged in each y value into the two equations, subtracting right from left in this situation, which I then put as a formula into my Google Sheet. So I entered the formula into my Google Sheet, and because my y value was entered in the C column, I was able to just plug in the C value for each individual row, and then that way it made the process a lot easier, and that gave me my diameter. And then from there, in the next column, I just did the entire D column divided by 2 for each row, and that gave me my radius. And then for semicircles, obviously, because the equation for the area of a semicircle is pi over 2 times radius squared, I made a column with just the constant of pi over 2. And then I finally had a last column, which was the width, which in this case happened to be a constant, which was again 1/4 of an inch, is 0.25. And then in my last column, I have h, which is where I find my total volume. So it was the radius squared, so I did my e column squared times my constant times the width. And then I did that so that it was set up so that it multiplied the e, f, and g of each row, and that gave me my areas. And then at the bottom of my volume, or that gave me my volumes, I mean. And then at the bottom of my volumes column, I set up a summation to add every single value in that column. And that gave me my final actual area of 28.292464662 inches cubed. And so then from there, so that was kind of my spreadsheet work to get my actual area. And then my definite integral was kind of, well, simpler than that, obviously. So because I had already established that I put it in terms of y, or in terms of x, I mean. So I set it up basically the exact same way or you would set up any semicircle. It was just in terms of y, and it's here on my poster. So I put the pi over 2 to the outside because it's a constant for both, so you can move it to the outside. So I had pi over 2 on the outside, and then I had the integral from 0 to 8 because it's in terms of y, or in terms of x, but so that way I then had my 1/6 sine of 4y plus 4 minus my 1/6 cosine of 4y plus 1. So that's my right function minus my left function. And then I divided that by 2 because that's equal to the diameter and we need the radius. So I divided that whole thing by 2, and then that value divided by 2 was then squared to give me my radius squared. So I was integrating my radius squared from 0 to 8 and then multiplying by pi over 2 at the end. Sorry, there's something on my screen. Anyway, and so pi over 2 at the end, and then that gave me my final volume of 28.3229101 inches cubed. So my theoretical volume was very, very, very close to my actual volume that I found, and it came out to a 0.1 margin of error. And I calculated that by doing my actual value minus my theoretical value divided by my theoretical value to get 0.00107, and then multiplied by 100 to get 0.107%. And then just to kind of give you a final overview of my poster from different angles. So here we kind of go close in, we have my singular slice, and now I calculated the volume for just that slice. That was my first slice, so the x or the y value was 0. And then I have like obviously like my kind of like background or like my additional like design feature. And then at the bottom here I have the actual cross section, which has a coordinate plane, and then it shows the intersection points of all 4 there. And then it has my sine function on this side, or my cosine function labeled on this side. And then obviously my cross-sectional pieces that kind of like vary side to side there. And then if we go further here, so if I jump on this side, then up top here we have my actual volume with my entire spreadsheet, and then summation, and then I kind of explain like what the total volume was, and it's the addition of all those columns of every value in that final column. And then I have my theoretical here, which is where I had my integral as I explained. And then I have my comparison at the bottom here as to why I had such a close, or such a low margin of error, because I used more slices. And so that was my total project. And then I labeled it Tigger at the top because there's a tiger. And that's pretty much it. Thanks.